Hello sir, hello classmates. This is the report of Group 8. Our topic for today is highway failure and their maintenance. A highway is any public road or other public way on land. A main road, especially one connecting major towns or cities. Did you know that the first highway was constructed on Long Island, New York, in the United States in 1911? Here is the first picture, and this is the second picture of the first highway constructed. So, what is highway pavements? There are two types of highway pavements: the flexible pavements and the rigid pavements. The surface course of a flexible pavement protects the underlying base course from traffic and water while also providing adequate tire friction, generating minimal noise in urban areas and giving suitable light reflectance for nighttime driving. Here are the different parts of the flexible pavement as shown on the screen. The rigid pavements are made of Portland cement concrete. The concrete slab ranges in thickness from 6 to 14 inches. It is laid by a paving machine, often on a supporting layer that prevents the pressure caused by traffic from pumping water and natural formations materials to the surface through joints and cracks. Concrete shrinks as it hardens, and this shrinkage is resisted by friction from underlying layer, causing cracks to appear on concrete. Highway failure. Main causes of pavement failures are rotting due to high variation in ambient temperature. In rainy weather, water can seep through gaps between aggregates and asphalt and act under tire pressure. As a result, the bitumen becomes more brittle, the appearance of cracks and leading consequently to a shorter pavement life. Uncontrolled heavy axle loads. If the highway or the road or the pavement didn't or couldn't handle the truck passing by or the vehicle passing by with carrying heavy loads. Inadequate stability. A role of a sub-base or base course is to transform the wheel load from surface course or wearing course to the subgrade. Therefore, the strength of the sub-base or base course is always higher than the subgrade. That means if the sub-base or the base course doesn't have enough strength, it will cause a damage to the pavement. Loss of binding action. When a wheel load is repeatedly applied on the road surface, it causes internal movement. Internal movement of the particles in the sub-base or base course. This results in relative movement between the surface course and sub-base or base course. In other words, instead of acting as whole, different layers act separately. This is the cause of alligator or map cracking in bituminous surface. Poor design and fabrication. If the design of the pavement or the road is not good or they use a substandard materials and aggregates to make this road, it will cause damage or failures to the pavement. There are four types or there are four major types of pavement failures. Those are cracking, distortion, disintegration, and skidding hazards. Let's go to cracking. Several different types of cracks can develop in asphalt pavements. The repair depends on the types of crack Some cracks are load-related and some are attributable to temperature or environment. First is fatigue crack. Fatigue cracking is sometimes called alligator cracking due to the interconnected cracks which resembles an alligator skin. Fatigue cracking is caused by load-related deterioration resulting from a weakened base course or subgrade, too little pavement thickness, overloading, or a combination of these factors. Block cracking is a series of large, typically 1 foot or more, rectangular cracks on an asphalt pavement surface. This type of cracking typically covers large area and may occur in areas where there is no traffic. Block cracking is typically caused by shrinkage of the asphalt pavement due to the temperature cycles. Edge cracking. Edge cracks are longitudinal cracks which develops within 1 or 2 feet of the outer edge of a pavement. These cracks form because of a lack of support at the pavement edge. Longitudinal cracking. Longitudinal cracks occur parallel to the center line of a pavement. These cracks are not load-related. They can be caused by a poorly constructed joint, shrinkage of an asphalt layer, cracks reflecting up of an underlying layer, and longitudinal segregation due to improper pavement operation. Transverse cracking. Transverse cracks occur roughly perpendicular to the center line of the pavement. Also, just like the longitudinal cracking, they are not load-related. They can be caused by shrinkage of an asphalt layer or reflection from an existing cracks or crack. Reflection cracking. Reflection cracks are cracks that form over joints or cracks in a concrete pavement or in an overlay of a deteriorated asphalt pavement. The cracks form because of the movement of the old pavement. Slippage crack. Slippage cracks are crescent-shaped cracks which form because of low-strength asphalt mix or a poor bond between pavement layers. The cracks form due to the force applied by turning or braking motion of vehicles. Second types of pavement failures is distortion. Distortion in an asphalt pavement are caused by instability of an asphalt mix or weakness of a base or subgrade layers. These distresses may include rotting, shoving, depression, swelling, and patch failures. Rotting is a linear, surface depression in the wheel path. Rotting is caused by deformation and consolidation of any of the pavement layers or subgrade. It is caused by insufficient pavement thickness, lack of compaction, and weak asphalt mixture. Shoving. Shoving is the formation of ripples across a pavement. This characteristic shape is why this type of distress is sometimes called washboarding. Shoving occurs at locations having severe horizontal stresses such as intersections. It is typically caused by excess asphalt, too much fine aggregate, rounded aggregate, and asphalt is too soft or weak granular base. Next is depressions. Depressions are also bird baths, are localized low spots in the pavement surface. These flaws can be caused by settlement or other failures in the lower pavement layers or by poor construction techniques. Upheaval is a localized upward movement in a pavement due to swelling of the subgrade. Frost heave is an example of this type of distress. Patch failures. When pavements are patched, some distress may begin to occur. The rate at which a patch deteriorates is influenced by compaction, material selections, and the quality of the surrounding or underlying pavement. Next is disintegration or disintegration. Disintegration is the breakup of a pavement into small pieces that are lost with time and traffic. Raveling and potholes are the most common types of disintegration. Raveling. Raveling is the wearing away of the aggregate particles from asphalt cement. This condition indicates that the asphalt has hardened or that has a poor quality mixture used. Raveling occurs in the presence of traffic. Potholes. Potholes are bowl-shaped holes caused by the localized disintegration of the pavement surface. Potholes typically results from the continued deterioration of another type of distress. Segregation cracks or failed patches may serve as the start of pothole. Poor mixtures and weak spots in the base or subgrade accelerates pothole failures. Last, skidding hazards. Skidding hazards are caused by water on the surface of a pavement, polished aggregates or excess asphalt, or other lubricants on the pavement surface. Maintaining a pavement which allows water to flow of a pavement is a basic consideration. Polished aggregate. Some aggregates are susceptible to wearing to a smooth finish or texture under traffic. This aggregate should not be used in wearing courses. If the aggregate polishes, the surface roughness must be restored. Last is bleeding. A pavement surface can be flushed with asphalt and lose its skid resistance. Bleeding can be caused by too much asphalt in the mix, excess tack or bond coat, or by poor construction of a seal coat.